Hello all, welcome to my channel. I hope you are all doing well in your life. So this is our next episode. This is our latest episode where today I'm going to talk about sampling and sampling distribution. In order to understand a particular topic, we must have this one question, which is why we are studying this particular topic. So let's say hypothetically we are taking this question, why we are studying sampling and sampling distribution, and what is the importance of sampling distribution. So let's understand this one by one each. The definition of sampling says sampling allows researchers to draw conclusion about the population without examining every individual. Okay, so what it means, as I told you previously in my videos, that when we talk about population, if we want to know what is the population of India, it is estimated to be 140 crores. So the population of India is estimated to be 140 crores. Okay. And if we want to know the sample, let's say what is the sample. So from this 140 crore, we can take a sample of 1 crore, which doesn't happen in the real world scenario. But anyways, we are taking it. So what we are doing is, out of this 140 crore, we have taken 1 crore sample as our size, which is our small n as 1 CR from the total 140 crore population, and we are doing a study on it. So this is very simple. Sampling is nothing but taking some sort of random samples out of the complete population and then studying on it. Okay, so we have some key topics over here. We have this simple random sampling, point estimation, introduction to sampling distributions, and we also have sampling distribution of mean x, sampling distribution of the proportion as well. Okay, this is x now we understood about just now we understood about sampling. Let's now understand this concept, simple random sampling. It is a method where each member of the population has equal chance of being selected. Ensure that the sample is unbiased and representative of the population. So what is the process of it? Use random numbers generator or draw names entries from that. Ensures that every individual or item in the population has an equal chance of being chosen. Let us understand this with the help of an example, or better understand. We are surveying a student's satisfaction in a university. So what we are doing is we are randomly selecting 50 students from a university student body to survey their satisfaction with campus facilities. Ensures each student has an equal chance of being selected, leading to unbiased research. So what we are doing is we are selecting 50 random samples. Let's say take an example of our college IBS. We have almost like around not around but at least 1000 students. We have 1000 plus students, so we are taking 50 students. So how we will take 50 students? We have sections from A to O, so two students from each sections, 2 or 3, and by this what we'll do is we'll collect these 50 students. We will ask them this question, rate from 1 to 5 on a scale of 1 to 5, how much satisfied you are with this university. So based on this we will generate a score. We will get some might rate 1, some might rate 5, some might rate 4, some might rate 2, 3 accordingly, and depending upon these ratings we can identify that whether these 50 students are satisfied or not. Based on the scores of these 50 students, we will calculate the average rating And after calculating the average rating, we can determine that the students who are studying in this college are highly satisfied, moderately satisfied, or least satisfied. Okay, this is how we can do it. Anyways, so now let's understand what is point estimation. So this is the whole thing which I have written over here. Let's just not read this. Let me explain you what is mean by point estimation in a very simple manner. So point estimation means x bar, which is also called as mean. Okay, that's it. So whenever the question asks you calculate the point estimate of this, you will have to calculate the mean. So here is the example, estimating average height. If you measure the heights of a sample of 100 people, the sample mean height is used as point estimate of the average height of entire population. So 100 people we are taking, let's say 100 are taken from a population of 1000. Okay, so 100 people each are having, some having 5 feet 11 inches, some having 5 feet 5 inches, like that. So after collecting this data, what we will do is we will calculate the x bar, which is our mean. So what we do the summation of x and then we divide it by the number of people. In this case we have 100 as a sample. That's it. This is all about point estimation. So here is the new topic, which is introduction to sampling distributions. So let's understand what it is. A sampling distribution is the probability distribution of a given statistic based on a random sample, meaning that we will have this whenever the word probability comes in, make sure that you draw this normal distribution diagram. So this is all this explanation means that a sampling distribution is the probability distribution of a given statistics based on random samples. Whatever random samples there could be, what you will do, you will do some statistics on it with the help of normal distribution. Okay, so now role in statistical inference allows researchers to make inferences about population based on sample. So as I gave you the example of satisfaction score among the students, we took the sample as 50 and we assumed that the whole population, that means the total number of student in an MBA batch, is estimated to be around 1000 plus or maybe 1400, something like that. So we have this population figure as 1400, we are only assuming it, and out of these 1400 we took our sample size as 50. So what it means that as I am a researcher, I am only considering this 50 as my sample size, and I am also doing some sort of study on this 50 number of samples. So this will allow me to make inferences about this whole population because I did the study on this particular sample, and I have chosen the random sample. Why? As I told you, I went from section A to O and selected a random students because I wanted my data to stay unbiased. Okay. Other thing is helps in understanding the variability and distribution of sample statistics. So we have statistical figures like mean, mode, median. Then we have standard deviation. We have variance. So this helps us in understanding all these statistical parameters. Okay. Now what it says, difference between population distribution and sampling distribution. Population distribution of all individual values in the population. Sampling distribution of statistics calculated from all possible samples of a given size from the population. We have this example. If we repeatedly sample test score from a class and calculate the mean each time, the distribution of these means from the sample distribution of the mean. Okay, so it means that the mean will show a distribution each time we calculate different things. Okay, so sampling distribution of x bar, sample mean. Okay, this is I explained you earlier. So but now we are learning distribution, so the case is different. Okay, so let's understand this. It's a very simple concept. Sampling distribution of x bar, what it means. So whenever sampling distribution term comes in, you always create this bell-shaped curve. Okay, so this middle point is our x bar. All right, and here comes in our standard error or standard deviation. So let's understand each one of these one by one. The definition says the sampling distribution of a sample mean is the distribution of sample mean values from all possible samples of a given size from the population. This is a mean value. Okay, then we have this term which is called as central limit theorem. It states that the sampling distribution of sample mean approaches a normal distribution as the sample size increases regardless of the population's distribution. So it is meaning that the sample, when it goes up, it approaches means it approaches towards a normal distribution curve regardless of the population distribution. Or in other words, we can say that the number of sample which we have, like if the sample is above 1000 or 1000 plus, in more bigger cases researchers do that, they consider sample size of more than 1000. So whenever in such a case, we can estimate or do our studies with the help of normal distribution curve when our sample size is more than 1000. Okay, so here we have the similar example. We have sampling the mean scores of group of 30 students from a large population of test score. As the sample size increases, the distribution of the sample mean approaches a normal distribution. So we have 30, but when we are going up, the normal distribution curve was like this. In the 30, it becomes like this. Okay, so this increases, the curve increases. Okay, earlier we had 30, then we have 30 plus. As we increase the sample size, the normal distribution curve also increases. Anyways, moving on. Okay, so let us understand what is sampling distribution of P, means sample proportion, what it is. So first of all, in order to understand sample proportion, it is really important for us to understand what proportion actually means. So as we have seen earlier or previously in our previous chapters, from the formula for proportion is x upon n, meaning that the x is the objective of samples and n is the total number of samples. Okay, total samples, and these are the objectives. So let me simplify this with the help of an example. Let's say we have a basket, okay, which has a lot of fruits. For example, we have total number of fruits in the basket as 100. Okay, and we came to know that we have 25 apples in the basket. Okay, so to find the proportion, they'll ask you to calculate what is the proportion of apples we have in the basket. So the formula is simple. Proportion is equals to x upon n. We know that our x is 25 because they are asking us proportion of apples. So P, which is equals to 25 upon total number of fruits. Okay, we have around 25% of apples in our basket, meaning that in the full basket we have 25 number of apples. Okay, Now let us understand the proportion. So sampling proportion is simple. As I told you previously, that we collect sample from the total population. Let's say, hypothetically speaking, for an example, so population meaning that the total number of students in 2024 MBA batch is our population, alright, which is estimated to be around close to 1400. I don't know the actual figure, but I am just taking it. So now what happens is, it has been found out that 500 students will opt for marketing major. Okay, so we have to calculate the proportion. That proportion for marketing major is going to be 500 divided by 1400, which is 5 by 14, which is our answer. You can calculate that. Alright, so sampling proportion is similar. In the case we take the sample, and here the standard error of the proportion is calculated with a very different formula, which is P into the bracket 1 minus P divided by N. Okay, this is the formula to calculate the standard error for proportion. Moving on. So where we use sampling, what are the practical applications of sampling? So real world scenario we have discussed, where this sampling method and concepts are commonly used. So it has importance in market research, public opinion polls, quality control, and we have also mentioned one of the market research surveys as in our example. Okay, so you want to see the consumer preferences. For example, you want to know which chocolate is consumed by consumers in IPS college. So what you will do, you will give them choices. Okay, and you will not ask each and every student from the 1400 batch size. What you'll do is, you will at least ask 100 to 200 students. Depending upon that, you can determine the which chocolate brand is preferred by most of the students in IBS college. Alright, so concluding to this topic, what we studied about what is population and sample. When it comes to population, we denote it by capital N. When it comes to sample, we denote it by small n. Then we understood about sampling distribution. Then we also talked about point estimation, which is mean, x bar. And then we also understood about proportion, sampling of proportion or proportion sampling, which is our P. Okay, moving on. So we have this simple problem right in front of our screen. We'll solve it. Okay, we have some data. The following data are from a simple random sample. They are asking us to calculate a point estimate of the population mean. So how we calculate mean? We denote mean by x bar. Then what we do, we have the following data, we add all of it, we sum it up, and then we divide it by the numbers of data which we have in the hand. So here in this case we have 6 numbers of data. Okay, so when we calculate it, it comes around 54 divided by 6, and our total answer is 9. So in this case, our population mean is 9. Similarly, we calculate the standard deviation. Okay, so standard deviation can be calculated with the help of a table. So we'll start creating a table: 5, 8, 10, 7, 10 and 40. Okay, then what we do is we do xi minus x bar. So in this case, what we'll do, xi is our 5 minus x bar is our mean, here 9. Okay. And now what we'll do is we will square it up. So 16, 1, 1, 4, 1 and 25. And in the last we will do is we will sum everything. Okay, only this column. So after summing it up, what we get, 48. Okay, now here summation of xi minus x bar whole square is equals to 48. Okay, so to calculate standard deviation, what we do is we use this formula, which is s is equals to under root of summation of xi minus x bar whole square upon n minus 1. So in this case we have root 48 by 6 minus 1. Our s will be equals to 3.09. Okay, very simple and easy calculations we did by understanding this very simple basic problem. Okay, so moving on to the next problem. So what this problem says, a survey question for sample of 150 individuals yielded 75 yes responses and 55 no responses and 20 no opinion responses. So we have total number of sample as 150. We have yes, no and no opinion. We have 3 type of responses. So we have 75 yes, 55 no's and 20 no opinions. Okay, this is what we have in our given data. So let's read the first case, which is asking us to calculate a point estimate of the proportion in the population who respond yes. So there are 75 responses which says yes, so we will only calculate these much. So for to calculate proportion, we have formula as x upon n. Our x is going to be the objective which I told you previously, which is only asking us to calculate the yes responses. So x is going to be 75, and with the help of 75 we will calculate the proportion. Oh, sorry, this is 150. This is 150. So 75 divided by 150 is going to be 0.50 or 50%. In the second scenario, we have to calculate for no responses. So our x in this case is going to be 55, and the proportion is going to be 55 divided by 150. So proportion is equals to p is equals to 0.366 or 36.6%. Okay, so this is how we do it. Okay, that is all We learned about sampling and sampling distribution. Thank you for staying till the end of this video. Have a good day.